Right now, as you hear these words, over 10,000 stars are being born somewhere in the observable universe. Each of those stars may host planets. Some of those planets may have water, atmospheres, even living things looking up at their own night sky, wondering the exact same question you are. So why, after decades of searching, billions of dollars in technology, and more than 6,000 confirmed exoplanets, have we found absolutely nothing? Not a whisper, not a signal, not a single hello. If you're curious about the hidden stories behind our world and beyond, you're in the right place. Consider subscribing. There's always another mystery waiting. Let's start with something that should make you uncomfortable. The observable universe contains as many as an estimated 2 trillion galaxies and overall as many as an estimated 10 to the power of 24 stars. That's a 1 followed by 24 zeros. That's more stars and potentially Earth-like planets than all the grains of beach sand on planet Earth. Take a moment with that. Every grain of sand on every beach you've ever visited, every beach you haven't, and the stars still outnumber them. Now, here's the part that really breaks your brain. About 1 in 5 sun-like stars are estimated to have an Earth-sized planet in the habitable zone. That so-called Goldilocks zone, not too hot, not too cold, where liquid water could exist. Assuming there are 200 billion stars in the Milky Way, it can be hypothesized that there are 11 billion potentially habitable, Earth-sized planets in our galaxy alone. 11 billion. And that's just one galaxy out of at most 2 trillion. So with numbers this absurdly large, the universe should be teeming with life. It should be noisy, crowded, maybe even annoying, like a cosmic group chat you can't mute, but it's silent, perfectly, eerily silent. And that silence has a name. In the summer of 1950, physicist Enrico Fermi was having lunch at Los Alamos National Laboratory with a few colleagues. The conversation turned to UFOs, some recent news reports, and Fermi, in the middle of the discussion, blurted out a question that sounds simple but has haunted science ever since. Where is everybody? That's it, 4 words, but the logic behind them is devastating. If the universe is billions of years old, and if intelligent life should be common, then advanced civilizations have had plenty of time to develop space travel, send signals, or colonize the galaxy. Even at relatively slow speeds, a civilization could spread across the entire Milky Way in just a few million years, a cosmic blink. If intelligent life is common, why haven't we found any evidence of it? This contradiction became known as the Fermi Paradox. But here's the strange part. Someone had already tried to do the math. The Drake equation is a probabilistic argument used to estimate the number of active communicative extraterrestrial civilizations in the Milky Way galaxy. The equation was formulated in 1961 by Frank Drake, an astronomer who wanted to calculate how many alien civilizations we might be able to detect. It was the fall of 1961, a year after his pioneering SETI experiment, Project Ozma. Using an 85-foot antenna in Green Bank, West Virginia, Drake had unfurled the intriguing possibility that we might find proof of intelligent beings by simply eavesdropping on their broadcasts. The equation looks complicated, but the idea is elegant. It was designed to estimate the likelihood of discovering active, communicative, intelligent extraterrestrial civilizations in our Milky Way galaxy. By combining a series of probabilistic factors, you plug in your best estimates for how many stars form per year, how many have planets, how many develop life, how many develop intelligence, and how long those civilizations last. Within the uncertainties of the involved astronomical and biological parameters, the Drake equation typically predicts that there should be many exoplanets, from less than 100 to millions in our Milky Way galaxy hosting active communicative civilizations. Millions. The math says millions. But here's the thing. These optimistic calculations are not supported by evidence, which is often referred to as the Fermi Paradox. That's only half the story, so we have 2 possibilities, and honestly, both of them are terrifying. Either we're early among the first intelligent civilizations in the galaxy, or something stops civilizations before they get very far. Scientists call this hypothetical barrier the Great Filter. It's the idea that somewhere between the formation of a planet and the development of an advanced galaxy-spanning civilization, there's a step so hard, so unlikely, that almost nobody gets past it. The question is, where is the filter? If it's behind us, say, the leap from single-celled organisms to complex life, then we've already beaten the odds. We got lucky. We're rare, and the universe is full of planets where life simply never got complicated. But if the Great Filter is ahead of us, that means civilizations regularly reach our stage of development and then don't make it. They destroy themselves. Climate, war, technology that outpaces wisdom. And that would mean our future is a lot more fragile than we'd like to believe. Scientists weren't expecting what came next. In 2022, researchers hypothesized that once a planetary civilization transitions into a state that can be described as one virtually connected global city, it will face an asymptotic burnout, an ultimate crisis where the rate of required innovation can't keep up with exponential growth. If a civilization develops the capability to understand its own trajectory, it will have a window of time to effect a fundamental change. They proposed that civilizations either collapse from burnout or redirect themselves to prioritizing homeostasis, a state where cosmic expansion is no longer a goal, making them difficult to detect remotely. In other words, maybe the aliens grew up. They stopped trying to conquer the galaxy and instead focused on sustainability. They went quiet on purpose, which honestly sounds like the most mature breakup ever. It's not you, universe. We just need to focus on ourselves. But there's another possibility scientists recently explored, and it reframes the whole question. Researchers proposed refining one of the Drake equation factors phi, the fraction of life-bearing planets on which intelligent life emerges too. Take into account the necessity of large oceans and continents and the existence of plate tectonics. For more than 500 million years on those planets, wait plate tectonics. The thing that causes earthquakes? That's supposed to explain why we haven't found aliens. Turns out, yes. In the original formulation, this factor was thought to be nearly 1, or 100%. That is, evolution on all planets, with life would march forward and with enough time, turn into an intelligent civilization. The researchers' perspective is that's not true. Their argument is surprisingly persuasive. The scientists suggest that the presence of both continents and oceans, along with long-term plate tectonics, is critical for the emergence of advanced civilizations. They consequently propose the addition of two factors into the equation: the fraction of habitable planets with significant continents and oceans, and the fraction of those planets with plate tectonics operating for at least 500 million years. Planet cross-section with tectonic plates, multiple planets getting crossed out, one by one. The modified Drake equation suggests that advanced civilizations are extremely rare, with the chance of planets having the right conditions being between 0.0034% and 0.17%. That's not millions of civilizations. That's closer to maybe none. This means there could be anywhere from as few as 0.006 to as many as 100,000 active communicative civilizations, with the actual number likely being on the lower end. 0.006. That number is below 1. Meaning, according to this model, there's a real chance we are statistically alone in the Milky Way. Here's the good news. We've never had better tools for the search, and the tools are getting extraordinary. The search for signs of life in the universe has entered a new phase with the advent of the James Webb Space Telescope. Detecting biosignature gases via exoplanet atmosphere transmission spectroscopy is in principle. Within JWST's reach, we can now look at the light passing through alien atmospheres and potentially identify the chemical fingerprints of life. As of June 2026, there are 6,298 confirmed exoplanets in 4,709 planetary systems, with 1,054 systems having more than one planet. That number was 0 just 30 years ago. Timeline with planets popping like popcorn, and it's about to get even crazier. NASA's next great orbiting observatory. The Nancy Grace Roman Space Telescope now has an official launch date. After it launches August 30th, 2026, the Roman telescope will create enormous cosmic panoramas. Scientists expect Roman will help settle essential questions regarding dark energy and astrophysics, discover more than 100,000 exoplanets, and spot hundreds more planetary systems as they're forming. 100,000 new exoplanets from a single telescope. Meanwhile, the SETI Institute hasn't given up listening. In 2022, the organization kicked off an initiative called Cosmic SETI, which leverages the scanning power of the 27 independent radio telescopes that make up the National Science Foundation's Very Large Array to look for technosignatures coming from advanced civilizations. We're not just passively hoping anymore. We're building the ears and the eyes to actually find something. But here's the part that rarely gets discussed. What if the aliens already know about us and they're deliberately staying quiet? Also known as the zoo hypothesis, the zoo scenario proposes Earth is deliberately left uncontacted, akin to an interstellar wildlife preserve. We're not being ignored. We're being observed. Multiple advanced civilizations may have appeared, millions or even billions of years before intelligent life developed on Earth. With such a vast head start, these first civilizations would have complete control over the universe. They'd be able to destroy or control less advanced forms of life, like humans have done on Earth. The fact that they haven't destroyed us could be evidence that they're choosing not to interfere, or it could just mean they're there. And we genuinely don't know which one it is. There's even a wilder idea. The planetarium hypothesis speculates that the universe is an illusion crafted by an advanced intelligence. Everything we observe, the stars, the silence, the vastness, could be designed to look exactly this way. Okay, that one's a bit much. But the point is, we've generated over 75 proposed solutions to the Fermi Paradox, and not a single one has been proven correct. So, where does all this leave us? Here's what I think is the most remarkable thing about this whole mystery. The Drake equation is more properly thought of as an approximation. We can't solve the equation. Not yet, maybe not ever, but the equation was never really about the answer. It was always a roadmap, a way of organizing our ignorance, of seeing clearly what we don't know, so we can figure out what to learn next, and look at what we've learned. 30 years ago, we didn't know if other stars even had planets. Now we've confirmed over 6,000. We've photographed black holes. We've tasted the atmospheres of alien worlds. We've sent a telescope 1 million miles from Earth that can detect the chemical signatures of life on a planet orbiting a distant star. We haven't found anyone yet, but we've barely started looking. Think about this tonight. When you look up at the sky, every star you can see with your naked eye, that's maybe 4,000, 5,000 stars. Out of hundreds of billions in our galaxy, out of trillions of galaxies in the observable universe, we've examined a thimbleful of an ocean and concluded the ocean is empty. Maybe the real question isn't whether we're alone. Maybe it's whether we've been searching long enough to even deserve an answer. If you enjoyed exploring this mystery with us, subscribe to There are countless fascinating stories still waiting to be uncovered. Until next time, stay curious.